Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. We are currently studying marine boilers. Today's lecture is an introduction to the components of water tube boiler. First, we will discuss the construction of Foster Wheeler external superheater reheat boiler and explain the purpose of various components used in the water tube boiler. Next, we will examine the flow of flue gases, water and steam in this boiler and discuss the methods used to control the temperature of superheated and reheated steam. Let us now go through each of these topics one by one in the following slides. Components of a large water tube boiler. Water tube boilers are used for high evaporation and high pressure applications such as driving propulsion and power turbines on steamships that require superheated steam. As steamships have largely been replaced by diesel powered ships, this description focuses on the basic concepts of large water tube boilers as shown in the sketch. The main components of a water tube boiler include a large furnace, a steam drum, a water drum, and headers, all interconnected by various types of tubes. In addition, the boiler may be equipped with a superheater, a temperature, reheater, and a superheater to control steam temperature for mechanical power generation and auxiliary purposes. An economizer and an air heater are usually provided to recover waste heat and improve plant efficiency. A brief description of these components is given here. Furnace. The furnace of a large water tube boiler is surrounded by tubes containing water which circulates to generate steam. One or more burners are fitted, typically mounted on the side walls or roof. In small capacity water tube boilers, the furnace may be completely surrounded by water, similar to a smoke tube boiler. Steam drum. The steam drum acts as a reservoir of relatively cool water and provides the necessary gravitational head for water circulation, except in forced circulation exhaust gas boilers used on motor ships. Water circulation in oil-fired boilers occurs naturally due to density difference caused by temperature variations. The density difference allows dry steam to rise and leave from the top of the drum, while the water mixes with incoming feed water and continues circulating within the boiler. The steam drum separates the steam water mixture and acts as a reservoir of steam, helping to prevent pressure fluctuations. Water drum. The water drum receives water from the steam drum through downcomers and distributes it to generating tube, screen tube, and water wall headers. It also allows suspended solids to settle. These precipitates are removed through blowdown connections as required. Headers. Headers perform a function similar to that of water drum but are smaller in size. Drums are large enough for entry through the manholes, while headers are accessed through handholds or plugs. Steam headers are used in superheaters. Generating tubes. Large number of small diameter generating tubes are placed in the main flow of hot gases, providing a large heat transfer surface where steam generation occurs. Mainly by convection, their minimum diameter is determined by allowable steam to water ratio to prevent overheating and tube failure. The number of generating tubes may be adjusted to ensure the required flue gas temperature before the superheater to achieve the desired superheated steam temperature. In modern boilers, generating tubes are often replaced by water valves, where steam generation occurs primarily by radiant heat from the flame rather than by convection from flue gases. Screen tubes. Screen tubes protect superheater tubes from direct radiant heat. Positioned near the furnace, they receive heat from the flame and hot gases. Their relatively large diameter maintains a low steam to water ratio, preventing overheating. Water walls. Water walls surround the furnace and contain its heat, significantly reducing the amount of refractory material required. Downcomers. These are large diameter unheated tubes placed outside the gas stream, supplying water from steam drum to the water drum and headers. Risers or return tubes. These tubes carry the steam water mixture from the water wall headers and back to the steam drum. Superheater tubes. Superheated tubes are small diameter tubes placed in the main gas stream after the screen tubes. They raise the temperature of saturated steam from the drum to the required superheated condition. Superheaters may be divided in primary and secondary passes. They must be protected from direct radiant heat because steam has a much lower specific heat than water, making the tube susceptible to overheating. Superheater support tubes, which are larger in diameter, provide water-cooled structural support. A temperator. A temperator controls the final superheated steam temperature. In modern boilers, it is usually located between the primary and secondary superheater passes. Desuperheater. The desuperheater reduces steam temperature for auxiliary uses where saturated steam is required. Although saturated steam can be drawn directly from the drum, this practice is generally avoided to prevent superheater overheating during low load operation. Reheater. A reheater increases the steam temperature after it has expanded in the high pressure turbine, preventing moisture formation and blade erosion in the low pressure turbine. Reheaters may be internal, that is within the boiler, or external near the turbine. Economizer. An economizer preheats feed water by recovering waste heat from flue gases, thereby improving boiler efficiency. Air heater. The air heater is typically an final heat recovery unit and preheats combustion air before it enters the furnace. Its location depends on the flue gas exit temperature. Excessive cooling of flue gases may cause sulfur dioxide condensation, leading to cold and corrosion. In some cases, bright steam from the turbine may be used to warm the incoming combustion air. Finally, the gas flow path. Exhaust gas is leaving the furnace, pass over screen tubes, generating tubes, superheaters, reheaters, the economizers, and the air heater before exiting the boiler. Flow diagram of flue gases, feed water, and steam. This sketch shows the flow of flue gases, feed water, and steam in the Foster Wheeler external superheater D type radiant boiler, which was one of the most advanced designs in its development series. This boiler does not have the conventional bank of generating tubes. These have been replaced by the monowall construction. Flue gases leaving the furnace pass over the monowalls and screen tubes and then transfer heat to the steam in the superheaters and reheaters and to the water in the bypass economizer and steel fin economizer as explained here. The feed pump supplies hot feed water to the steam drum through the steel fin economizer and the bypass economizer, thereby recovering waste heat from the flue gases. Saturated steam from the steam drum is sent to the superheaters to raise its temperature. To control the degree of superheat, the superheaters are divided into primary and secondary stages. A partition wall divides the gas stream into two parts with the flow control by link dampers consisting of reheat control and gas bypass dampers. The primary superheater has four steam passes. The first and second passes, along with the bypass economizer, are regulated by gas bypass damper. When reheating is required, the flue gas flow in this section is reduced. The reheat control dampers regulate the gas flow over the third and fourth passes of primary superheater, the first and second pass of the secondary superheater, and the reheater. Reducing the reheating effect increases the feed water temperature by directing more flue gases over the bypass economizer. The degree of superheat is controlled by a temperature located between primary and secondary superheaters, that is within the steam drum, as well as by regulating the flue gas flow over the superheater surfaces. If the final steam temperature at the superheater outlet rises above the set value, the steam temperature controller T diverts a portion of the steam to the temperature A. This lowers temperature steam rejoins the main steam flow at the inlet of the secondary superheater, thereby reducing the final outlet temperature. The superheated steam leaving the boiler is then supplied to high pressure turbine. The exhaust steam from the high pressure turbine having a reduced degree of superheat is returned to the reheater to raise its temperature before entering the low pressure turbine, which exhausts into the vacuum condenser. Reheating prevents turbine damage caused by erosion and corrosion due to moisture formation. Auxiliary steam for miscellaneous services is obtained by passing superheated steam through a desuperheater D located in the water drum, producing nearly saturated steam. This boiler was capable of producing 68,000 kg per hour of steam at 45 bar and reheating the steam from 322 degrees Celsius to 454 degrees Celsius. This completes the study of introduction to the components of water tube boiler and the flow of flue gases, water and steam through Foster Wheeler ESRD boiler. This book has been written by me and covers all the topics as per Indian Maritime University syllabus. It explains key concepts using simple illustrations. The book also includes answers to all questions that have appeared in examination conducted by Indian Maritime University. It will help students prepare effectively for exams and also support them in working safely with ships' boilers. I hope you enjoyed the lecture. Feel free to share your feedback in the comment section. If you found the tutorial helpful, consider sharing it with your friends. Subscribe to the channel to stay updated with the upcoming tutorials. I'll be back soon with a new lecture. Thank you for watching till the end.